How long would it take?
1 million.
Sorry?
1 million.
1 million. Good. Does everybody understand how it gets 1 million? Is 100? Yes. So you need 1 million combination, but most of the time the lock will be in between. So before you get to the 1 millionth combination, you might actually open the lock. So if someone writes a program to open this, the computer has to be fast enough to do 1 million combinations and find out which one would open the lock. Clear? Imagine if we had a constraint, and I'll talk about this now. So for this kind of generate test approach, it has to be complete. That means all the combinations must be available. It has to be non-redundant, and it must be informed. This 100 combination is not a really informed system. But I'll move to the next slide. Imagine if we put constraints and we say that in this combination that we have, it's only a prime number. That's a set of constraints. What that does for you is that it limits the amount of process that has to happen, because we have 25 prime numbers. So all of this number to 97, they all make up. So all prime numbers are 25. So for each of these, there are 25 combinations that we need to go through. And you see that dramatically reduces the number of combinations to 15,000 plus. So when you design a problem or you represent a problem, the more you understand the constraints that can lead to your answer, the better. So if someone designs this and goes with this, it's good, but it's not informed. But if it's informed that you only need prime numbers, that's a constraint, and it makes your algorithm to work faster, and it makes you to be able to get your solution easy. This is basic of artificial intelligence. This is the basic of it. But the real people that develop all of this, there are so many approaches that people continue to research every day, and they're beginning to learn a lot more about it. But this is just a flavor of how things work. And the assignment, you can actually see how this also relates to the assignment when I talk about the output, and you compare it to this. And so the more you define your criteria, the more the constraints. And your criteria are dependent on your experience, on understanding what these venture capital banks really want. So those constraints will help you to eliminate, it helps you to narrow down on getting to your ideal combination. So that's what representation of a problem and also an approach to problem solving, that's what that is all about. We can still take this a little bit and still talk about it, but that's just an introduction for you guys to have a feel. That was meant to be a question, by the way. So how many countries does the equator pass through in Africa? How many countries does the equator pass through? Okay, I think there are really smart people here. Yeah, so those are 6 countries. And this is how you want a computer to be able to think. You communicate with the language, and your language system communicates your visual system, and that visual system performs an action, and your language system responds. Imagine if I can tell a computer that, and it can actually make that happen. That's a problem, but you need to actually write the algorithm, write the constraints for the computer to be able to solve this kind of problem. That's how the human brains, that's how it works. But how do we get the computer to also act in that way? So the answer is actually sick. But the idea is that how can we get computers to actually get to that kind of level of you communicate with them through natural language. So right now we have to first represent the problem, and we have to put constraints, and we have to represent it in zeros and ones for it to understand it. Imagine if you just speak to a computer and you can just take that information and process it. That is what we call artificial intelligence. And that's where a lot of people are pushing that frontier to get to that point. So how did we get to where we are as humans? And a lot of people that have researched this theory, I don't know if you guys know about Noam Chomsky, is a very old guy. And he's really done a lot of research and trying to understand how did humans get to where we are? How did we get a lot of intelligence? And the key thing that he came up with is that it's language. So he said, at some point, he said some of us, like thousands of years ago, acquired the capability to take two concepts and combine them to make a third concept without disturbing the original two concepts without limits. So I told you about these guys, the way they communicate sometimes, you really, really need to understand what they're trying to say. But in simple terms, what it means is that humans learn how to begin to describe things in a way that is intimately connected to language. So you can think about human beings as at some point, people just made sounds. They weren't coherent enough. But a set of group now really thought about it and said, let's put, two concepts together. And you could see how I'm trying to describe the representation, using it to associate it with the assignment and all of that. That's a skill set that humans have. And you put two concepts together to describe a third concept without disturbing the two concepts, and people understand it. So what I've been trying to do is put different concepts together and try to explain it. And you guys are also getting it, and you're getting knowledge. So language is the core and fundamental of how humans have intelligence. So what we are trying to do is that we are trying to help computers to really get to understanding natural language. If they get to that point, maybe then they can start acting intelligently. And so thinking is just, so a little bit details of that. So we think with our eyes as well. When we see stuff, and we're able to describe things, we tell stories. And storytelling leads to understanding, which I believe you guys are understanding what I'm trying to say. And that is what education is all about. So from language, from describing two concepts, coming up with third concept, we begin to learn, we begin education. And that's how we become more intelligent. And clearly arrange our perception. So perceptual and perception, and when I talk about I want you guys to think, I want you guys to challenge yourself, it results to creativity. So clearly arrange our perceptual system, command our perceptual system to imagine. So when I say imagine things, think about data that nobody has been looking at. Think about how can you capture those kind of data. The combination of your imaginative system. And when I was talking about business models, I want you guys to think wide. That's what brings our creativity. So it's so interesting to see how language and intelligence tie together and how all of these things has evolved and how we are trying to push the frontier with computer systems to also do the same. So this takes us to the concept of what we call machine learning. And that was the concept you were asking me before. So how do machines get the ability to learn without being explicitly programmed? So when we put constraints, when we put all of that, what we are doing is programming it. But we want to get to the point where we don't need to continue to do that, and the computer itself start being able to program itself and having the ability to take action. That's what you call machine learning. So in the topic of artificial intelligence, you will hear people talk about machine learning. Yes, please.
Would there be texting and the phone picks up on the word that you're about to use?
Yes. That's also artificial intelligence. Have you guys noticed the phenomenon that when you use a certain word, for example, in my language, there's some words that I use. After some time, when I use WhatsApp just understands it, and it doesn't try to give you a correction. Do you guys experience that? Yeah. Right? That is, sorry?
Okay, so like the iPhone, the word y'all in the South, but it doesn't really recognize it. But I think they've changed it, hopefully. There's certain words that they don't.
Yes, yeah. Probably there's still a lot of words. But what I realized that when I use a word continuously, after some time it doesn't give me it doesn't tell you to change it anymore, right? It doesn't correct you any. Sorry?
It memorizes those words.
Yes. So that's exactly what, that's an application of machine learning.
It does it with the playlist of music too, if you like the same kind of music, you play the same kind of music.
Yeah. So that's actually, so those are real applications of machine learning. Is how can machines start, understanding some of these things and actually taking action. So maybe it would play to you at a certain time of the day that you like it to be played. So that's artificial intelligence. But I hope I've been able to give you guys a little bit of background an introduction on the basic level of what it's all about. And I also appreciate the fact that you guys did that exercise to see how representation is really important. So we talked about Watson the other day, and I'm just going to touch a little bit about it again. You can see Watson is learning to think in Japanese. So we're trying to push the frontier where they can actually learn natural language. Because when they start learning, when they can learn in natural language, you don't necessarily have to represent that problem in zeros and ones anymore. They can actually start picking up on natural language by themselves. Question? Yes, please.
But doesn't any computer at the base level still think in zeros and ones? So they would never actually be able to think natural language because it's all still in binary code?
Yes. The reality is that they still, I mean, at the end of the day, they still think in zeros and ones. So what happens is that people leverage on understanding. So when you build a software or something and you patent it, when the next person is trying to build an application, it layers on top of what you've layered on. So it doesn't necessarily have to code it to the point of zeros and one anymore. So when you speak natural language to the computer, it's still doing the representation of the problem, but it's now doing it by itself. Guys, this is a very good question. So the question is that, will we get to a point where computers don't actually deal in zeros and one anymore? The answer is no. We're advancing in such a way that we are really standardizing a lot of applications and a lot of software that you can actually leverage when you're now designing a computer that can learn from natural language. So for example, Watson, for example, they're saying is learning in Japanese, but when you speak Japanese to it, it has to first do what you call the representation problem. It has to represent that data, and that data is voice. And voice comes in sound waves, and those waves are zeros and ones. So, for example, Watson is learning Japanese, and we are thinking, when we speak to it, we want it to understand what we're talking about. And this is data, because voice, it's what is a wavelength. It's like a wave. So imagine a wave like this, different pitches. And it's all of these points are data points. And there's something called the decibels or decibels. And that, so you hear about minus 40, minus 100, whatever that is. Guys, can you follow me, please? So when someone says that a computer can learn by natural language, the fundamental still goes back to the zeros and ones that we talked about. But there are different steps in that process. So firstly, Japanese is a language, and you speak. And now I'm telling you that is data. And data can either be, it could be text, right? And text has, in English, for example, is A to Z. A can be represented in terms of zeros and ones. 7 can be represented in terms of zeros and ones. And you also have numerics as a form of text. So the character 0 to 9, they can also be represented in terms of, so 0 is 0, 0, 0, 0. 1 is 0, 0, 0, 1. And all of this can be represented in terms of zeros and ones. So when you have someone speak and his voice, it's a wavelength. And that wavelength, this comes to representation, can be represented in terms of a wave. And each wave has an associated number to it. And once you have a number, what can you do? You can translate that number to zeros and ones. So anything, any form of data, pictures, videos, voice, they always go back to zeros and ones. But all of this has been standardized. So when somebody writes an A, there's a standard, it's called ASCII. It's association of something, something, I can't remember. Yeah, so they've standardized all of this. So when you put A, it understands that this is this. So when you speak and there's a number, it can translate to this. So if it's a video, for example, it does the same thing. It translates. Colors all colors are also zeros and ones. Everything, any data point you can think of that a computer can access and process are all zeros and ones. The only thing that is not zeros and ones right now are your thoughts. Because it's difficult to project your thoughts, right? It's difficult. It's a data set of data, but if you've not projected it by writing it or by voicing it out, it's still data that is within you. But any other thing that you can think of, it's data, apart from your thoughts. Maybe in the future, maybe we'll be able to read people's mind and actually extract that kind of data. Any questions?
So basically, in every different colors or different objects or video, you have different combinations of zeros and ones, right?
Yes.
That's how it's practiced.
That's how it works. So colors, we have what you call, who knows how we represent colors? Pixels, that's it. Yeah, and primary colors. So every color is a mixture of, what are the primary colors? Red, what? Blue? No. Come on. Oh yeah. Red. All right, guys. I can't believe we're having this debate. Can somebody Google it for us, please? Please, guys, you can use your computer. Please Google primary colors for us.
How do you not know this?
Because everybody.
Primary colors a computer uses are different to the ones that we think are primary colors. Yeah, they want computers that have one color.
Yeah, so I want you, guys. So the primary colors are a combination. I mean, every color is a combination of the primary colors in a definite proportion, right? So for every color that we have is a proportion of the primary colors. Unfortunately, your professor can't even remember the primary colors. But it's important. So those kind of basics are important. But it's not only me. There were so many of you that can't even remember what primary colors is. So that's fine. We're all the same. So what the basic... Sorry? Red, yellow, blue. All right. So but actually, guys, he cheated. He actually Googled it, right? But yeah, I think it's actually. So every color that we have is actually a combination of all colors, and the primary colors have zeros and ones associated with it, and it kind of does that, and that's what we call pixels. So let's move on. So I have a quick question, and this question is just, guys, this is a reflective question. What do you guys think? Guys, can I see show of, and what do you guys think? So we've established about a few minutes ago that data scientists are the sexiest job. We've made them like the all in all of everything. But now, what about if Watson, we're talking about artificial intelligence, what about if it can actually do the work of data scientists in the future? What do you guys think? Yeah, tell me, I mean, I want more context. Yes.
I think eventually, yeah, in like 100 years, when artificial intelligence is pretty much the same as our intelligence, but not.
Okay. Any other point of view? Yes, please.
But Watson will be able to make decisions that are emotional or
That's a good question. So guys, I agree to what he says because he said 100 years. But let's think about it like a limited number. So let's talk about 10 years. What do you think? Do you think that with all this capability, what will happen?
So I think it says help with decisions. It doesn't say decision making. So that's where humans come in.
Okay. So maybe that slide I'll update it. Watson will be able to make decisions in the near future.
I don't think so. I mean, you have to have like some kind of superhuman for that to happen, where like an actual human and a computer combines. Because even like a genius only knows 1% of everything.
Yeah. Sorry again? Good. That's actually what I want you guys to reflect on. And remember that at least for the next few years, I don't know what would happen in 100 years' time, but the fact is that anything or any complex problems always would, for at least for now, will require so in the near term, I don't think that Watson will replace all the data scientists because these are really, really complex problems. So just representing those problems alone, I don't think that computers will figure that out so soon because you need a lot of algorithm, you need a lot of coding, statisticians. It's a diverse kind of skill set that you need. And you're still talking about emotions and stuff like that. So I think that always reflect on that humans and computers will have to work together to get the best. So when humans and computers have to work together to be fully optimized. And the reason why, so we're here to learn, and we can easily get carried away with all this superpower, all this super, good stuff that all these computers can do, and people will start getting to the point where they say, we don't need these humans anymore, computers can do everything. In my opinion, in the next near term, yes, it's going to disrupt how we live, but any situation or any problem that requires both of them to work together, that's actually the best scenario. So keep that in mind. I think I've stressed that during the assignment. I'm stressing it over again. You get into organizations, you get into discussions with people, and people can tend to say computers will do everything, but remind them that humans will continue to be relevant. So that's one of the key takeaways you have from this kind of class. So let's look about, so I talk about Google a lot, I talk about IBM, and I said these guys are in the frontiers of artificial intelligence. I'll take about 2 minutes to just read through how Google actually use artificial intelligence. So I'll give you guys 2 minutes to just read through that and kind of digest it.
So based on what you said, is Siri an artificial intelligence as well?
Yes. There's a lot of capability that's built into Siri now that makes it AI. So if you read through this, you'll see some of the interesting stuff. So much of the work done in language and speech, so Siri is a speech, translation and visual processing relies on machine learning. So you can see how I explain it, but you need some sort of machine learning for the computer to start learning by itself. We talked about WhatsApp as an example, how you start remembering the words that you use. We're talking about Siri. So all of this is important in terms of how do you use AI. So contrary to much of current theory and practice, the statistics of the data we observe shifts rapidly. The features of interest change as well. And the volume of data often precludes the use of standard single. So again, and that's why I said that it's going to be tough for computers to actually represent these problems because all of this is moving fast. And again, I talked about the ideal combination. So for example, in our assignment, we talked about, guys, take this seriously. We talked about our assignment and we talked about the system being able to look for an ideal combination. Do you think that ideal combination will continue to change? Yes? How many people think it will not change?
Think what?
Okay, so in the assignment, I spoke to you guys about the ideal combination, and we are always trying to compare the output versus the ideal combination, right? The question I'm asking is that, do you think this ideal combination will remain static over time? Who thinks it's going to be static? Good. So it's not going to be static. It's going to move. It's going to be dynamic. So the way you want to design your system is that your system is intelligent enough to know that it's moving, and it can actually now start relating the data points to where it moves to. So that's why I said you guys really need to spend time to think about the assignment. So if one of you guys just put what I told you guys and submit it, but if the team is able to understand and tell me that this ideal combination will continue to move, but we will design a system to have artificial intelligence to be able to adapt to it, that is a better assignment. But already I've told you guys again, but there's still so many things that you will discover on your own if you spend time to think through this, and you can actually see how all of this kind of tie together from big data and artificial intelligence and all of that. You can see how it ties together. Facebook as well. So this is just looking at Facebook and what kind of components of Facebook use artificial intelligence. So the posts in your timeline, the ads, the features like speech recognition, automatic, would find this very interesting. Every time you post a picture, it tells you who that person could be. Yeah. That is artificial intelligence. Automatic image tagging is driven by artificial intelligence. And Facebook is just getting started. The social media company's new personal helper. Have you guys used this before? So look out for this. Can help you make dinner reservations, buy things off Amazon, and even recommend gifts for your spouse. That is what you call artificial intelligence. So it kind of knows the kind of restaurants that you go to, and it can actually make a reservation if the prices are low, and it feels that that price is lower than the average price that you pay. It can buy that for you. It can buy things off Amazon, for example, if the prices are really low, and it thinks, and personal helper thinks that you like that kind of stuff. So, but it will be a setting. You probably set it up that buy stuff, if you find out that it's cheaper and stuff like that. So that's what you call artificial intelligence. And what do you call all of this kind of stuff? Sorry? Sorry? So I think I've put that off. What do you call this? So when the personal helper can do all of this, there's something there are two things I've talked about in the class that you can actually relate to that. So you move from data to what? Then what else? What is after business intelligence? Action. Action. So you can actually see that this is action. And when action is involved, that's what you call artificial intelligence. You can see that then it's taking action based on the data personal helper has. It's taking action on your behalf. Also, that's what we call being optimized, full optimization. Then it's taking action on your behalf. So one of the things that are interesting for Facebook also is, so this is something that, because I usually listen to Mark Zuckerberg, he has a lot of town hall. Has any of you listened to his town hall before? Okay, good. So Google also has what you call the Google I/O. Has anyone listened to Google I/O? So I think every year there's what you call Google I/O and the Facebook Town Hall. If you want to learn about all the new stuff that is going on, those are two. So those are two resources that you can, if you just want to learn about new stuff, they're always talking about the new things that they're doing and they're working on. And one of the things that was from that town hall was that Facebook, one of the use cases of AI would be to read content, filter the content, and quickly remove unfit content. At the moment, Facebook does that manually. So that's one of the challenges that Facebook has at the moment. They have a bunch of guys that work on the content. So when people post stuff that other people's do not like or violate stuff, there's a reporting mechanism that you have. That's a process. You report it. Then someone has to humanly assess that and take that off the media or leave it there. That's a very complex situation, and that's a very complex process, and it's currently manual. But what Mark was saying is that that's one of the things that they want to use AI to do. So AI will be able to read the content and quickly remove it if it feels that the content is unfit. So that's one application that they're trying to pursue and to get to. So what does this mean for us? When we talk about data, business intelligence, and Watson and all of that, it means that it means that technology is becoming more democratized, and there's going to be a lot of opportunities that will come from it, from big data, from business intelligence, from artificial intelligence. There are lots of opportunities that are going to come out of it, and that's what I want you guys to focus on. And I hope that the last 3 classes that we've done, I hope you guys, at least you're getting some more knowledge about all of this topic, and I hope that you put that into your assignment, and I'm going to see papers that are going to be wow. Okay, so we are going to finish 2 minutes early today. We'll continue the next class. We'll finish up the bit of AI. Then we'll move into consumer internet business model. Thank you, guys.
Thank you.
I'll take this question, please. Guys, we have one question. Technically, the class is not over. I wanted to release guys 2 minutes early, but we have a question.
How will you call a phenomena where machines,
Guys, please be quiet and loud and clear, please.
where machines can actually read your mind?
All right, guys.
Okay, I was watching a video where 2 persons were connected to a computer, and one was thinking something, and the other was acting according to that profile.
Guys, can you hear the question? So the question is about, she said she's seen in a scenario or in a movie, and someone was thinking, had a thought, and the next person could.
Yeah, he was acting according to his thoughts. I mean, he was thinking to slap someone, and he was just slapping without even, without his consent.
So guys, I think this is an area that and nobody has gotten to that, where you can project your thoughts and stuff like that. But I can tell you that people are thinking about it. So if you watch the Facebook town hall, Mark actually talks a lot about thought projection and being able to see that. But at the moment, it's not happened. Would it happen in the future? I don't know whether it will happen, but I think it's...
Actually happening because they were showing it.
Guys, oh, was it a movie?
No, it was TED Talk.
It's like a disease.
Oh, so it's a disease?
Computer was reading the thoughts. I mean, you can actually...
Guys, we have just 1 minute more, please. Let's listen to her. Yes, please.
Where a computer was reading the thoughts of one person and the other person was acting according to whatever he was thinking.
Projecting that, actually, honestly.
All right, guys. I've not seen that before, but if you have a link to that video, I think you can share with the class. That would be nice. So maybe if you send that to me, I can play it in the next class. But that's a thought. So, at the end of the day, you need to be open. Things would happen. There's going to be, like I said, there's going to be a lot of disruption. And I see them as opportunities that can actually change how we live. So, yeah, good point. All right, thank you, guys. See you